dear students, in this video we are going to study about finding inverse of matrix, which is application of the last application of the determinant we are going to use. And here we are going to define the adjoint matrix, and for the adjoint we need the definition of the cofactor. You remember the cofactor matrix from the matrix, let's say here from this matrix. If you are going to get the cofactor matrix, minus 1 to the power of m minor, it should be, let's say, the ith row and jth column. And then we were getting the cofactor matrix. If you remember from the previous videos, we were getting the cofactor matrix like this. Then here in the definition it says that the transpose of the cofactor matrix is called adjoint matrix. And while we are using this adjoint matrix, if A is invertible, which means that determinant is not equal to 0, firstly, then A to the power of minus 1, which is A inverse, is equal to 1 over determinant of A times adjoint of matrix A, it has to be. And let me remind you about the cofactor, finding the cofactor. Let's say if I want to find the cofactor of first row and third column, which is here the 4 we are going to close, and which means that it's going to be equal to minus 1 to the power of 1 plus 3 times the minor. What was the minor? When you close first row and first column, that was equal to 2, 1, 1 and 0 it was. So C1, 3, it was equal to minus 1 to the power of 4 times, we are going to write this is equal to 2 times 0 minus 1 times 1 it was, which is equal to C1, 3 is equal to 1 times here minus 1, which is equal to C1, 3, it should be equal to minus 1. Here I used long maybe expression, but while we are calculating we are going to make them shorten, and we are going to continue with the exercise now here. Here we are going to calculate the adjoint matrix of A. Here, adjoint matrix, to calculate the adjoint matrix, we should find the cofactors. So I need to find one by one, C1, 1, and that's equal to minus 1 to the power of 1 plus 1. And first column, when I close here, it's going to be equal to the minor, it's going to be equal to 1 minus 1, 0 and 1, which is equal to here, let me continue from here, minus 1 to the power of 1 plus 1. 1 times 1 minus 0, which is equal to 1 times 1, so it's equal to 1. C1, 1 is equal to 1, it has to be. What about the C1, 2? Let's write here, not like it is not the continuous. C1, 2 is equal to first row and second column. We are closing, then minus 1 to the power of 1 plus 2 times the minor, it becomes 2, 1, and minus 1, 1 it should be, which is equal to minus 1 to the times 2 times 1, it's equal to 2, 1 times minus 1, it's going to be equal to 1 times minus 1, it should be equal to plus minus 1, which is equal to minus 1 times 2 times plus 1, it's equal to 3, 2 plus 1, it should be minus and minus, which is equal to 3, minus 1 times 3, it's equal to minus 3. So C1, 2 is equal to 3, it should be. Then we are going to continue with the C1, 3, which is equal to minus 1 to the power of 1 plus 3. First row, third column, when I close, the times it's going to be equal to here 2, 1, 1, 0, which is equal to C1, 3 minus 1 to the power of 3, 4, which is equal to 1 times 2 times 0 is 0, and 1 times minus 1 it should be. So C1, 3 it's equal to 1 times minus 1, which is equal to minus 1, it has to be. Sorry for this one. Here 1 times minus 1 it's going to be, which is equal to minus 1 directly. We can write here, I wanted to clean this part, is equal to minus 1. Now I'm going to fasten the video, so Now if I continue from here, from these givens, we are going to find the cofactor matrix. Like this is the cofactor matrix. It's going to be here 1 minus 3 and minus 1, and then 0 minus 3 0, then minus 4, then 9 and 1. It has to be, this is the cofactor matrix, and adjoint of this matrix, it's going to be equal to, adjoint of this matrix, it's going to be equal to 1 minus 3 minus 1 times here, and 0 minus 3 and 0, and that's going to be equal to minus 4, 9 and 1. It has to be, this is the adjoint of the matrix A. The matrix A here, this is the adjoint of A. It has to be. Okay, let's continue with the next question. Now we are going to, by using the adjoint form, we are going to use the we are going to find the here inverse of the matrix A. So I have to find firstly determinant of A. I know the adjoint A from the previous question. So for the determinant of A, I have to find the cofactor expansion. I'm going to use the cofactor expansion, and for the cofactor expansion, I'm going to use this here column. 0 times, this is the entry, minus 1 to the power of here, first row, second column. This is plus first row, second column, and times the whatever the here, whatever the minor is, the result is going to be 0. That's why I didn't write that one. And then 1 times minus 1 to the power of, this is second row, second column. So times here the minor, it's going to be 1, 4, 1 and 1. Then, and the last one, it's going to be 0 times, this is third row, second column, minus 1 to the power of third row, second column it's going to be, and third row, second column minor is 1, 2, and 4n minus 1 it's going to be. But whatever this is, it is not important for us, because we are going to, this 0 makes everything 0. So this is completely equal to 0, and this is equal to 0, it's going to be. And here this is positive, so it means that if this is positive, I mean minus 1 to the power of 4, it's going to be positive. This is going to be equal to 1, which means that the determinant of A only, it's equal to 1 times here 1 minus 4. It has to be, which is determinant of A is going to be equal to minus 3. Okay, if the determinant of A is equal to minus 3, then here we are going to by using the property adjoint form, determinant of A inverse is going to be equal to 1 over determinant of A times adjoint of A. And here the 1 over minus 3 it's going to be, and from the previous page I'm going to here take this part. I'm going to try to take this part, adjoint of A, and let's copy here, copy, and if we paste to this part here, paste here, so I copy and paste the adjoint of A, and we are going to multiply by 1 over 3 this one, and it's going to be equal to here 1 over when you multiply by 1 over minus 3, which is equal to minus 1 over 3. This is 0 minus 4 over minus 4 times 1 over minus 3, it's equal to 4 over 3 it has to be. And then here 1 over minus 3 times minus 3, it's equal to 3 over 3, which is equal to 1 also. Let me write directly 1. And since it is minus also, this is also 1 it has to be. Then this is going to be here it's equal to 9 times 1 over 9 times 1 over minus 3, it's going to be equal to minus 3. Then this is going to be equal to 1 over minus 3 times minus 1, which is 1 over 3, 0 here, and that's going to be equal to 1 over minus 3. Minus 1 over 3 it has to be. Okay.